Okay, so Lab 9, this is going to be your last assignment in the class. It's also going to be effectively the final in this class as well, so just keep that in mind. So we're going to look at the laser fire for the space war, and it's basically we're looking at line and circle interactions. I've provided you three things. Basically, a Unity package, and that is, what we look at here, it's basically this Lab 9 scene, the Lab 9 grid, and a basically show results. So if we press play and we look at it, basically you've got all the interactions. The one thing is that with the line circle is now, and this is fully completed. We'll go over that. But basically it's got this piece going on. So we've got this interaction going on. To get this, so when you import, go back to, here we go. So when you import the package, it's going to yell about missing methods. That's okay, because you actually need to go and add. If you go, come on, load canvas, just text file. There we go. So I've given you there's 4 methods that you need to add to the collision code. Your collision code. And I've given basically stub code for basically everything. So the first one is does line intersect circle. The next one, there's another does line intersect circle, and it takes basically 2 drawable objects. So basically this is a hack. Basically, I'm giving it 2 objects to basically, which are going to be the drawing. Basically, think of this. These are the drawing objects that are going to be basically the points. If I have an intersection on a circle, it's going to draw the points. These are the 2 drawing points. So this is kind of a hack. You would use this one. These 2 methods use this method, basically intersection point, which takes the first point. The second point, this is your line start, line end, the center of the circle, and then the radius of the circle. And right now, it's basically it's taking it's generating a vector results. So result is a list of vector 3s. We'll go over why we'll talk about why that is. And then finally, there's one more. It's a utility function that you'll need in this version. You're gonna check is point in a line segment. So this assumes that your point is on a line somewhere. Now, when we talk about a line, there's the idea of the line that extending out beyond the segment to infinity. So we're asking if this point is within the line segment, and that's going to be important. We'll go over the code in a moment. But I'm just saying for you, when you get started, you could basically just copy all of this and add that into the collision tools. In fact, I'm actually going to grab all of, I'm going to do that. Come on. There we go. Okay. And it looks like I forgot some semicolons. I'll go back over, grab all these again. There we go. Okay, I'll upload this new version in a moment. But basically, again, this is you can see already right now that the code is using this right here. Is line in a segment? Basically, we're asking if this point is inside these 2 points that are on the line. And this is actually not hard to do. I'm going to do a. There we go. So the big thing is that we need to check if the x and y values are within the start and end. The only thing is that we don't know which of the start and end points which is the lower value. So this is really basically a math f min, and this is going to be start x end dot x. And that's if this is less than, we'll do it equal to point dot x. And that is, so there's going to be, again, four of these. And then there's going to be math f dot max start dot x n dot x, and we want it to be, this is going to be point dot x less than or equal to. So these are all going to be and I'm basically going to grab these two lines as it is, and I'm going to basically go from start x going to be y's instead. And I can take off this and bring that. So essentially we've got 4 checks that we're doing. So if the smaller of the x and y is less than or equal to the point dot x, it's inside. If it's bigger, if the point is smaller than the bigger of these two, then it's inside. And we're doing the same. And so all 4 of these have to be true to be correct. So that's your inline segment. We will need to use this inside this intersection point. Let me. Why is this? Oh, but I don't need to. Oh, that is correct. What's going on? Oh, okay. I need another. So just to make sure that. There we go. Why is it yellow? Oh, and this one needs. There we go. There we go. All right. Okay, we'll save this. So the answer here is let's go look at the basically. We'll just delete this. So basically, what we are going to end up using is intersection point. Yeah. So intersection point. P1 is going to be line start, line end, circle center, circle radius. So this is what we're passing. What we want is yeah, let's just use the result. There we go. All right. So first thing I'm going to do is I'm going to call this the work function with the values that we're going to do. We're here, and that function is going to return back basically a list. We know that if result dot count is equal to 0, turn false. So if we have no intersection points, then we know that, hey, then there's going to be nothing here. Otherwise, we're going to return true. And that's going to be, for our purposes here, that's going to be our primary, like our workhorse result. I'm really going to grab this one more time. I'm going to grab this in, and what I'm going to go, and I'm going to paste this in. So the one scenario that I do have here is that I do need a count equal to 1, and this is going to return true. What I want to do is make sure that, why is this a, there we go. Okay, so in this case, I want to make sure that intersect 1, perform draw, come on, it's equal to false. And I need to put the return, this is an order of operations. It's yelling the fact that, there we go. In case of count number 1, this will be true. And what I also want to do is intersect sorry, I need a capital. My God, I can't type today. All right, intersect position is going to be equal to our result at 0. So the first point is going to be, and we'll understand where that comes in a moment. Just basically going to grab these lines of code. I'm going to drop this down here. This will be true, and then it's going to change. So intersect 2, the second point, is going to be equal to the second element in the array. I mean, in the list. So that's basically this is the structural pieces, and this is what that function is looking to do. If there's nothing, it's going to turn them off. Doesn't really worry about where they're positioned because they're not being drawn. In the case of where there's one result, it will turn on the first point, set it in that location, and it'll turn off the second one. And then otherwise, we've got two points. It will go through and set, turn them both on and set their positions respectively. So this is a hack. This is a hack to show where the lines are. The enter. All right. This is you would normally not do. This is written this way for convenience, for the sake of this lab, to demonstrate what's going on. So, all right. Let me go back to the lab assignment. So, there we go. All right. So now that you've got that, the big piece right now is the intersection point code. And I've given you an implementation of it. I'm going to take literally everything inside here. All right. I want you to note that this is returning back an array of vector 3s. We are going to change that up. All right, so let's go in, and I'm literally going to drop this code in here. All right. So one of the things that this is doing, basically, if the lines don't intersect, basically it's trying to return back a vector of zeros. What we want is just basically return result here. It's trying to return. There's a here where they have this where it's finding the intersections. So it creates 0 and 2. Right now, for our purposes, what we want to do is basically let's return the result. But what we want to do is result dot add sect 0 and so we are always going. So this is going to be problematic. This is not what we want, but basically, that's basically what we want to change. We're going to return back not both segments always, but only the ones that are actually relevant. We'll worry about that one moment. The other thing that we need to do is that if we want to look at the distance between get the distance between the X and Z on the segment, that's the implementation is correct. The axis is wrong for our project. We're working on the X and Y. Like they're on the plane X and Z where you normally would be. We have gone because we're on screen space. We're in X and Y. So everywhere it's referring to a dot Z, that's really a dot Y. So this is really going to be an X and Y. So we got to go through, and you can see right here, first we've got these Z's. Turn them to dot Y's. Because we're not working on the Z axis, we're working on the Y axis. Here's another dot Y. And I know this is busybody work, but I want to point out hey, this logarithm is correct. It's just not on the axis that we are using. Center Z Y. And there's down here. X, Y, and there we go. Okay. So with those changes in place, we should be able to get up and going. The collision tools should be working. So let's jump back to Unity. That's the hub. There we go. So if I press play, you can see that the line right now is not intersecting. That's correct. Controls. Left and right mouse. So left mouse button and right mouse button are going to change the points. So you can see right here that this line is here. It's going through the circle. There technically is again, go get closer. This is a line. Think of it as a full. It's going through the circle itself.
It's like a ray.
So the issue that we have is basically it is while this as a line is going through to infinity, it's going through a circle. The segments should be. It's not showing up. That's interesting. Let me just look at the drawing tools just quickly. Not drawing tools. Collision tools. This was working. Why is it not setting the position on the intersect? I go back to where I had before, where it was working. Okay. I've only moved. Yeah, why is this acting weird? All right, I'm gonna come back. I'm gonna be. Yeah, the only difference is. Let me grab these 2 lines of code. Just see if that's. Okay. All right, it's doing what I wanted, what I was trying to show before. So basically, you can see that here's the line going through the intersection point. And you can see that like whereas my segment is here, my intersections are over here. And so the solution to that is basically to go in and basically say, hey, ask if it's in the line segment. So if sec0 is between the first point and the second point, again, this is line start, line end is what we applied. And here is segment 1. Again, if it's in the line segment, add it to the list. And again, basically, we want to just make sure that this is inside the line segments. So if we go back, Unity, and we start again. So with that check in play, you can see that while that is, like, in theory, going through it on that, the infinite line, only when it's actually crossing through the line barrier that we are getting these points. You see, I'm going through that. So in theory, if I could get this perfect, and this is the problem, is I'm not going to get this perfect. I'd have to like go in and set up the line to be perfect. When there's no intersection, you get no points. When it's segmenting the circle like it is, 2 points in this scenario, 2 points, or like this, you're going to get 2 points of solution. 1 point if it's only crossing like this. That's specific to our solution. But there is another 1 point solution, and I can't get it. It's the tangent of the line tangent, and that's going to be, there'll be 1 solution. You've got to be perfect exactly on the line to get that tangent. And I'm not gonna, given the magnitude of error of where points are and whatnot, I'm not gonna get that unless I set that up in code, like specifically. Like if I set the line, let's go back. So if we go back to the grid 09, where is it? Circle object position. So Here's the circle object. Here's the circle object. So I set it at a vector of 20 at negative 25 with circle radius of 15. So if I set, where's the line? Here's a line test. So I set it at 5, 5, and 10, 5 going across the top. If I set this to 5, negative 30. So I'm going down that 5. I should be getting a tangent if I set this up correctly. Yeah, here we go. So you can see that I've got, so it will do the tangent correctly, where I should be getting one result. But that's what the tangent would, in a perfect day, that's what that tangent's going to look like. Again, I had to set this up, I had to do some math to jump through hoops to set this up so you can show you what the tangent looks like. But that's, what's going on. And that tangent, again, I'm doing on the side of the circle because that's the easiest place to set this up. So technically, that is the, when you have only one point of solution, technically that is a tangent. Given how we've implemented, when it's going through the circle like this, I've got 2 points, but if I got only one point in the circle, I'm only going to end up with 1 point of intersection because we're eliminating the other side. Because that point's not on this line segment. So that's a quirk of how we implemented this. All right. So far so good in terms of how things are set up. Again, the big one in the code. Let's go back to the collision tools. Make sure that you set these to the .y's instead of the .z's. Again, we're going to set up a list, and again, we are going to return. Again, here we have no results, so the result has no values in it, so we're just going to return nothing. And then we're going to check each. Again, we'll get 2 points. Based on that theoretical line, and we're going to check each one individually. And here is another way of writing out the return. Again, min of the start of x and start and end of x. The max of the start and end of x. So. All right. That's part one, is basically to implement this code. You can see right here, count right here, form draw, false, 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 points equals 1, 1 is true, set 2 is false, set the position of 1 to 0, and then return true, and then true, true, positions, turn true. That is your first part. Second part is we're going to use the implementation from part 1 to create a laser that fires. And we'll have it check against all moving objects except for the ship that fired it. So let's go back. So let's go into the... I believe I need to go to the ship parent is where a lot of this work is going to be. Things that we needed to know is where's the laser start? Where's the end position of it? How long should we show? We need a counter for it as well. There is a laser object. Where's laser object? There we go. And we also added a line that's going to be the laser object. So we're going to create the laser object. Should be, yeah. So so the big thing, and we also added a Boolean So let me isolate these. So these are all. This is everything we need to deal with the laser properly internally. Could I have done another? Should I have done another object that does? That's a engineering question. But everything we need for the laser is going to be here. I'm going to Boolean that basically. So when we stop and set up, basically we'll set the laser object. We'll set it to the color yellow. So that's the one thing in setup A and B that you need to do. In tick, there'll be an update laser. And basically, if it's basically the Boolean, if we're not drawing the laser, then we just return. We don't do anything. So obvious Boolean operation that you've seen before. If we're drawing the laser, that means that we have some sort of value laser. So the laser show counter, we're going to subtract time from it. So when we jump down to fire laser, it becomes basically turn on that Boolean, set the counter to the time that we want. So we actually don't need the grid or scene index in this case to deal with this. So let's go back to if the laser counter is less than 0, then we'll turn off the Boolean and won't do anything else. Then finally, basically, we're just going to update the start and end positions. So it's going to use the ship's position plus, again, we're using the circle radius point. So center 0, rotation degrees, laser start. And then at the end, we've got end laser. So basically, we're going to draw from a certain, so so we're going to start from 5 units in, going to 100 units out. And basically, we're just going to update these end and start positions based on the radius. So, we want to draw this based on our rotation, our current rotation. And there is our get rotation. So center, rotation, length. And then we're actually going to the space war grid, and we're just going to draw a line on the laser object. So if we we will save this. Let's jump back to Unity right now. Oh, I'm still running. That's why. Let's jump back to the Space War project. So there's nothing that we've had to update to the Space War this scene as it is right now. And you can see that so as I rotate, it's going to, again, I'm doing a half a second just so you can see. That's a lot of time, but still. You can see that as I'm rotating, those points are updating correctly. So right now, those are the missiles getting destroyed by the ship. So in that case, the laser swipes through the missile because we're not doing any collision text. So let's stop. So that is now we're drawing the object. This is update laser is being called every tick. So this is the update. All right. I am going to. Yeah. So the big thing is that what we want to do is let's make a new function. Public void laser collision. I'm just going to move this into its own. Basically, we're going to detect I'm going to move this as its own function just to isolate it from because we just to keep this function tight and compact. So basically what we want to do is I want to go check. Go to missiles. Gotcha. Okay. So when we let me just look at this. Missile. I'm going to make our lives a little bit easier, and I'm going to basically going to this vision circle. Yeah, I'm going to do a public void remove missile. And I'm basically copying this section of code right in here. So that will make our lives easier in the long run, where we can basically like, hey, tell it to remove this object and make sure it removes. The other thing that we're not doing in here is actually remove object. No, that's fine. Let me just check. Go to definition. Move this. Where is the remove list? Gravity. The problem that we're dealing with is the drawing good. The issue that I'm dealing with right now is that there's two lists that they're in. What's the remove list? Okay. The one thing that we need to actually let's grab this. So it should be in the tick. So here is we get input. We tick grid, tick scenes. So this is the tick that we'll get. This is where either grid or scenes we'll call on our objects. Then we've got cleanup scenes. The problem that we're dealing with right now is that do we have a movable object? No, let's go to the spacework grid because I believe, yeah. So moving object list is set up here. The problem we're facing is that we have a list of things that are going to be drawn, but we also have a list of things that are part of the moving object list. And what we need to do, let's go back to the drawable grid. So where is cleanup scenes? Okay, I'm gonna grab this. I'm gonna copy this. And so I'm gonna do this after tick. And this is gonna be an override. All right. What we need to do is like, so for each item in remove list, so item.value, we remove at, again, we have to remove because it's a dictionary. In the case of, so the other thing that we can do is ask, what we, so if item.value, is a moving object. Is that correct? Actually, we'll do moving object mo is equal to moving object item.value. Why is it yellow? Oh, it's not value. Sorry, this is an integer. This is we want the key. Key to projection level. This is be a pain. This is a, so this is going to be a drawing. Call it thing item dot key. Is it a capital? Maybe a capitalization matters. Okay. Okay. So basically what we're asking, if the item.key is the drawable object in the dictionary. So if that is a moving object, what we want to do is basically moving object list remove let's do mo. And then we can go grab mo and just drop in. Do we want to do? Actually, if not equal to null. So the issue is that we need to cast to the moving object. Let's take this out. All right. So in this case, I'm asking, is this object a moving object? And I've done this a little. This is one way we can do this. The next way, the other way, you'll see this probably more often. Temp cast if not equal to null, and then we'll remove at that list. There we go. So either attempt the cast and check if it's null, or ask if it is, and then make the cast. I'm going to leave this version. So you can see that this is an action here. So the idea, if we remove something from the remove list. So again, this is just making sure that when we call, let's go back to missile. When we call remove object, if that object is, making sure the grid basically says if it's a object that needs to be that is a moving object, we want to remove that from that list as well. So something that I probably should. There's a question whether I should push the moving object list down to. I mean, the other question is, should I have moved that down to the like what I'm doing here with cleanup scene? Should I move that down to the drawable grid? Where is it? There it is, drawable grid. So should I push that down to this function, to this level of the object? And it's a question. For now, I'm going to leave it as it is because I did override it, and it should handle things correctly. Let's save everything. Yeah. Okay. So this is going to be literally is a for each. Moving object mo in, and this is going to be space war grid self moving object list. Okay, so the first thing I need to do is make sure that it's that. So basically, we know there's only three things. There's three things that's going in that list. It's ship A, ship B, and all the missiles. So what we want to do is make sure that if the moving object is equal to this. Oops, let me put. We found ourselves. In fact, I'm going to put a debug.log laser found. Skipping ourselves. And then we can go if mo is ship parent, actually what we can do is this is more than we what I probably should be doing. Yeah, no. Hold on. What I probably should do is after. So I'll skip. I'm debating where. All right. So what I need to do is basically is if collision tools does line intersect circle, and again you can see there are going to be two overloads. Basically, this is the start line end, circle center, circle radius. And what our purpose here is going to be laser object start laser object dot end. So this is the start and end point. And then we're going to go to mo dot collision circle dot. Oh no, we just need its position, because the center of the collision, because we've set up the center the center of the collision is on the center of the object. So wherever it is, that's going to be the center of the circle, effectively. And then we just need to go to MO collision radius. There we go. So does a line intersect circle? And basically we're asking true or false. So we're not, all that, 1 point, 2 point, that's all abstracted underneath. Again, we're calling essentially, hey, get the points. If the points are equal to 0, return false. Otherwise, return true. So this is the version we're using. So we don't have to worry about where the points are. If you get concerned about where the points are, then, you're jumping down to this version of the not that version. Sorry, you're jumping down to this version of the function. But we'll talk about that. There's a reason you jump to this version, but let's just keep this version for right now. So collision tools does line intersect circle. If that's the case, the first thing that we want to do is, hey, if it's a ship parent, how do we want to handle that? If MO is missile, in the case of the ship parent, I don't have a way to determine whether it's A or B. That's a good question. Public bool is ship A. So just so that we have that in play, just so ship A is true. And then this one, that allows us to go back to the spacework grid. Public void record if ship A, else just make sure that this is going to be ship B. Where did we do? It's in the missile. Okay, it's player A score. Where is... There you go. Ship A, player A score, player B score. Okay. So some way I can now that I know the ship, I can now basically I can just send their that Boolean over. Go back to where's the ship parent? So this is going to be Space War, grid self, core kill, is ship A. In case of the missile, what we want to do is MO, so it's going to be, we're going to cast it. We don't need to check because we've already said it's already. We know this is going to work because we've checked this already. So in this case, we're going to go missile, remove missile. Actually, yeah, we can handle it like that. And that should handle the our primary purpose of what we're trying to do in this lab. The only reason you might do check for the point is that, hey, I want to know where the missile hit. What where and that might be being too precise with the missile because it's a small object as it is. Because I want to use that, I want to know that point, so I'm going to put a basically an effect on screen, or but this is the laser, so ideally with this remove missile, I mean, I would probably go back to save the parent. Where's remove missile? Again, here is setting, removes itself from, if I wanted to do an explosion, I could create a drawable object that basically, ideally I could create I could create a drawable object that basically is a circle that expands, for like a couple seconds, or several rings, or but that's a decorative element. Something you would want to do, but for purpose of time and constraints of the if you'd like to do that, please do so. That adds an element to this game. Missiles explode. Ideally, I should be checking. These I should probably, for that purposes, I should be using remove missile instead. Oops. Make sure I put semicolons in. So that's something that I'll probably make that object later this week, because that's fun. That's the fun coding stuff, is making those little objects that that add moments. I mean, this is also probably I'd probably create a sound effect manager that would then I would just call the sound effect manager and say, hey, play this sound effect. That's probably a dictionary, like a string sound asset type thing, where I'll just add a string and a sound asset. I'll create that on the fly because I can. Or no, that might probably no, that'd be a Unity script. No, that'd be Unity script. I build a dictionary, and I'll build a public dictionary. Yeah, I probably would build a public dictionary to handle that. Just to bring up what I'm talking about. Let's do create sound. So I'd be a public. Again, I need to be using system.collections.generic public dictionary string sound. Sorry, it's audio clip. Sound list. Go to C manager. Do I need to serialize the field? That's not what I want. Why is the dictionary not? It's not doing what I want. I mean, it's not doing what I want per se. Um, I probably have to jump through some hoops to get this correct. I might have to make a structure that's serializable. Yeah, let's just let's try this with sound item. So this is a struct. Does not inherit. We don't need starter update. Public string. Name. Public. Audio clip. Clip. Here we go. Serializable. And let's go back to sound effect manager. Public list. Sound item. Sound list. Should here we go. So here we go. So here is, Pew. And I know I've got, did I give you Pew? No, I haven't given you any sound assets. So this is where, again, now I can set up this sound manager. And so I'd call this to play this. And what the other half of this is that basically I would make a prefab that has essentially an audio cue. An audio source on it, so that I could just make the idea is that this object is going to handle all the audio cues. So I'm just going through and reusing those. I'll make like 24 or 36 of them, so that as I call this, I'm just going through that list of just use this one, play. So I'm not reusing the same audio cue over and over again because remember, if you use the same audio cue, you play one shot, and do another one shot, it will override the first one. So we're just basically using different audio cues to handle what's going on. And again, this is because I'm not too worried. One scene application, not that big of a deal. So. This is sound effect manager, totally extra. So what I'm doing here is like totally extra. This is as if you were to build this out as a full application. These are the little things that you'd be building to help manage, doing things. Basically, I'm pulling all the sound cues so that they're not all over the place in this case. Where basically this object knows a string. It just says, hey, manager, play this string. And if it has it, it plays it. So there's a lot more work in the sound effect manager that will be, there's a lot more work in the sound effect manager that we need to do before it's actually ready to go to use. But, the idea here, is we're isolating our systems. So we're not worrying about this or that in other places. Let's actually. All right, let's get this out of the way. And for sake of argument, I'm going to go back and Where's the parent? Ship parent. And I'm going to crank this up to 200. Just so I have enough room to play with. There you go. So that, if I've done this correctly, is it not recognizing? Should be. Should be going through it. Let's go back to ship parent. There we go. We'll just say last quote. Oh, that's interesting. It's start, end, position, circle radius. Let's go check. Here's the ship parent. Until does laser object start, laser object end. That's correct. What's the position? To just look at moving objects quickly. Hold on. Collision. Oh, I got too many stuff open. Moving object. is it not? That's a good question. Should parent? No, we're keeping it on the grid. So I'm missing something. Radius. That's. It's not finding. That should be the issue. I'm gonna have to go back and look at why this is not working. Let me see, missile. Is it how I'm creating the missile? Missile object, create collision. That's a moving object. Radius. Collision circle. Just for the sake of argument, let's go in, put in the circle. No. Oh, I am. That's not it. This whole. Tick. Oh, okay. Let's go back to. So it is finding the ship parent. So the question is the radius on the missile too small? That's a good question. Fire missile, create collision. Let's set this to 5 right now. I'm gonna say that maybe that the collision is too small. It's not firing at all. What's going on? Okay. Oh, it is colliding with the ship right away. Let me see. I need to go. We'll just do 20 just to put it outside the ship for right now. There we go. Okay, so it's not registering the hit. Let's see. Parent. I'm wondering if this is causing a problem. Oh, hold on. I've got the return in there. That's probably what's going on. Yeah, that return. That basically, yeah, that's. I didn't want to return. There we go. I think it was skipping ourselves, and then not doing the rest of this. There we go. There we go. That was the problem. So let's go back. Let's get the correct ship thrust. Let me see. Launch at 13. Public float missile radius is equal to 2. Yeah, this is one of those. Probably, yeah, not ideal. Where is it? There's the fire missile. Here we go. Okay. I fire, and you can see right now. So it is now working. So it is recording hit with ship parent. So we got to go again. This is one of those. Where is? actually, if ship parent, actually, here's how we're going to do it. If MO is kill ship A. What we want to do is let me see. Ship parent MO. Let's wrap this around its own parentheses. Is ship A is equal to this dot is ship A. Sorry. Actually, we'll do the is not. So if they're different, then we'll send the record kill. So basically, if we were using this as a way to figure out, hey, if they're not the same, then we've hit another ship. If they're the same, then we don't want to record the kill. And we'll see this, descent over and over again. So little things. Press play. You can see found hit with missile, found hit with ship here. Again, this is going to go over and over again because of the issue with basically it is going to find the laser is inside the ship, the parent that we're firing from. That's why we're, that again is going to find the ship parent over and over again. So one, quirk of the system we're working with. All right. Any questions for me? Any other questions? No? All right. In that case, I'm going to stop the recording here.